Planes of the future. The end of the jet age. With emerging technologies redefining aviation's future, the jet age is coming to an end very soon. With reduced emissions and increased efficiency, electric and hybrid electric propulsion technologies are poised to transform air travel, while hydrogen fuel cells provide a zero-emission option. Electric vertical takeoff and landing aircraft, or urban air mobility, have the potential to revolutionize metropolitan transportation. However, this will require creative air traffic control and infrastructure. Advancements in AI-powered autonomous aircraft are improving safety and operating efficiency through sophisticated automation, while supersonic and hypersonic flight are making a comeback with the potential to significantly shorten global travel times. All of these developments point to a significant transition away from conventional jet-powered aircraft and toward a new era of speed, sustainability, and intelligent technology. The belief that the jet age is coming to an end is gaining popularity as new inventions and technologies change how aviation will operate in the future. The following significant patterns and advancements may herald the end of conventional jet-powered aircraft and the beginning of more sophisticated substitutes. 1. Hybrid and electric aircraft. Mobility technologies are being rapidly revolutionized by electric and hybrid electric propulsion in a variety of industries, including automotive, aerospace, rail, and marine. Our electrification research at Airbus aims to set the stage for future industry-wide and regulatory acceptance of alternative propulsion systems for airplanes, helicopters, and urban air vehicles on the route to flying with less carbon. To realize the aviation industry's decarbonization aim, a variety of technologies are needed. These include implementing sustainable aviation fuel, enhancing infrastructure and operations, and advancing technological innovation. Promising propulsion systems, such as hydrogen fuel cells and hybrid-powered aircraft, are being developed further. The industry, along with engine makers and other sectors like the car industry, will work together to address this significant challenge. A research and development agreement was formed in November 2022 by Airbus and Renault Group to utilize synergies to expedite the electrification roadmaps of both companies. An agreement to promote research on the next generation of semiconductors, which are essential to the aerospace industry's shift to hybrid and completely electric aircraft like the ZERO demonstration or the Airbus NextGen, was signed in June 2023 by Airbus and STMicroelectronics. Hybrid electric powertrain for aircraft. An aircraft that is hybrid employs multiple energy sources while in flight, either simultaneously or alternately. The combination of electricity with jet fuel or sustainable aviation fuels maximizes total energy efficiency and minimizes fuel usage. Better energy management is achieved using hybrid electric propulsion, which can cut fuel use by up to 5% when compared to a conventional flight. Batteries or fuel cells that transform hydrogen into electricity are two possible sources of electricity. Airbus debuted its engine fueled by hydrogen fuel cells in November 2022. Fuel cells for hydrogen. Through a chemical reaction with oxygen, hydrogen fuel cells are devices that transform chemical energy from hydrogen into electrical energy. An electrolyte, a cathode, and an anode make up the fundamental structure. Hydrogen molecules divide into protons and electrons at the anode. While the protons move from the electrolyte to the cathode, the electrons travel through an external circuit to create an electric current. The only byproduct produced at the cathode is water, which is created when oxygen molecules interact with protons and electrons. Because of their excellent efficiency and minimal emissions, hydrogen fuel cells are a desirable substitute for fossil fuels. They can be used for many different things, including supplying buildings with backup power or powering cars like hydrogen fuel cell cars. The high cost of production, the requirement for infrastructure for hydrogen distribution and storage, and the energy-intensive nature of hydrogen generation all pose obstacles to its broad adoption. Notwithstanding these obstacles, continued study and technical developments keep making hydrogen fuel cells more practical and effective. UAM, urban air mobility. Urban air mobility is about to undergo a revolution thanks to the arrival of electric vertical takeoff and landing aircraft, which will soon provide air taxi services for people and goods in cities all over the world. As operations grow and mature, UAM is anticipated to become a commonplace means of transportation in some areas. To facilitate the implementation and expansion of UAM in an internationally standardized manner, several airspace and air traffic management issues must be resolved. There will be more flights and quicker turnaround times, leading to an increase in the tempo, density, and complexity of aircraft operations in urban areas. Solving the special ATM problems related to battery-powered, piloted, and passenger-carrying operations will be critical. To adapt to this new environment, ground infrastructure will also change. Different organizations will handle many vertiports that serve different fleet operators. Over the next 10 to 15 years, a wide variety of these aircraft will reach service, but initially, eVTOL aircraft will be piloted. The increasing number of uncrewed aircraft systems in urban airspace will correspond with the rise of UAM. Drones and current users of airspace will eventually be integrated with both piloted and unmanned electric aircraft. Thus, a variety of piloted, remotely piloted, and autonomous aircraft with different sizes, propulsion systems, and payloads will be present in urban airspace. In certain places, the demands on urban airspace in the future will exceed the capabilities of current ATM systems and airspace management. Regardless of the kind of aircraft, a more sophisticated strategy is needed to safely expand operations and provide fair and equal access to airspace. ATM in urban environments has to grow to accommodate new and existing users of airspace, including piloted and uncrewed aircract operations. New ATM services will probably include UAS traffic management principles designed with urban airspace and all users of airspace in mind. Further advanced ATM services are required then for other airspace segments due to the challenge of integrating new urban airspace operations with existing aircraft. As a result, creating a unique concept for urban airspace is a top priority for the business. Travel at super and hypersonic speeds. Long-distance transportation is about to undergo a revolution thanks to the revolutionary advances in aeronautical technology that supersonic and hypersonic travel represent. In commercial aviation, supersonic travel, defined as flying faster than the speed of sound, has been made possible by planes like the Concorde, which flew from 1976 to 2003. Passengers may cross the Atlantic Ocean in less than 4 hours thanks to supersonic travel, which drastically shortens flight times around the world. However, because of high operating costs, capacity constraints, and environmental issues like fuel consumption and sonic booms, the Concorde's operations were halted. Advances in aerodynamics and materials science are currently driving the return of interest in supersonic travel, with new players creating quieter, more efficient supersonic jets to try to offset historical shortcomings. However, hypersonic travel, which entails traveling faster than Mach 5, represents an even more audacious leap, with the possibility of crossing continents in a matter of minutes. At the moment, hypersonic technology is in its experimental and developmental stages. Much research is being done to find solutions for problems including severe heat, aerodynamic stability, and propulsion systems. Countries including the US, China, and Russia are making significant investments in hypersonic research to achieve previously unheard of speed and efficiency for both military and commercial uses. Hypersonic flight has the potential to significantly cut travel times and improve global communication. But achieving these advantages would require overcoming significant financial and technological obstacles. As supersonic and hypersonic flight continue to advance, they have the potential to revolutionize our understanding of and experiences with international travel while pushing the limits of aerospace efficiency and speed. AI-powered and autonomous aircraft. A revolutionary development in aviation technology, autonomous and AI-powered aircraft combine powerful artificial intelligence with high-end automation to improve operational capabilities, efficiency, and flight safety. Modern sensors, machine learning algorithms, and data processing systems enable these aircraft to complete difficult jobs with little assistance from humans. Autonomous aircraft can analyze enormous volumes of real-time data, including weather, traffic patterns, and system health, by utilizing artificial intelligence. This allows the aircraft to make well-informed decisions and adjust to changing situations. This feature not only lessens the possibility of human error, but also optimizes fuel and flight paths, saving money and improving the environment. Furthermore, AI-powered systems can provide airplanes with the high precision necessary to carry out operations like automatic landing, collision avoidance, and remote piloting. The combination of these two technologies also makes it easier to progress in the area of urban air mobility, where air taxis and autonomous drones have the potential to completely transform transportation by offering on-demand, effective services. But for autonomous aircraft to be widely used, issues with cybersecurity, legal frameworks, and public acceptability must be resolved. With continued development, these technologies have the potential to completely change the aviation industry by increasing safety, dependability, and accessibility. In conclusion, as cutting-edge technology replaces conventional jet-powered aircraft, aviation is about to undergo a significant transition. Companies like Airbus are spearheading research into these developments, which might transform air travel by cutting fuel consumption and pollution through the use of electric and hybrid electric propulsion systems. With its high efficiency and low emissions, hydrogen fuel cells are becoming a more viable option, but infrastructural and cost issues still need to be addressed. Urban air mobility, made possible by electric vertical takeoff and landing aircraft, is anticipated to revolutionize air taxi and cargo services in cities, necessitating the development of new infrastructure and methods for air traffic control. Even with its previous limitations, supersonic and hypersonic flight is becoming more advanced thanks to new technologies that offer speedier global connectivity. Ultimately, with enhanced automation and machine learning, autonomous and AI-powered aircraft are revolutionizing flight operations by improving safety, efficiency, and adaptability. When taken as a whole, these advancements herald the end of the jet age and the start of a new chapter in aviation history that will be defined by sustainability, quickness, and sophisticated automation. Enjoyed the content? Make sure to like, subscribe, and drop a comment below. Your support helps us bring you more awesome content. Let us know your thoughts and what you'd like to see next.